for 6.2 example number 1, we're asked to integrate or find the antiderivative of x squared minus sine of x using U substitution. Well, actually, we're going to get into U substitution, but for right now, this is a pretty easy one. So, the antiderivative, in other words, what do I take the derivative of to get x squared? Well, it's x cubed over 3. Because if I take the derivative of that, I toss the 3 to the front, then that gets divided by 3, and then I subtract one of the powers. So this is the antiderivative for x squared. Now to get negative sine, that's the derivative of positive cosine of x. And since we do not have an upper or lower boundary or limit, then this is a family of functions. And since they didn't give me a point, and they didn't ask for a particular solution, although they wouldn't here, that is the antiderivative. And that's pretty much it for example number 1. Okay? And so, not too hard. Well, that's easy, but sometimes we're not so lucky. So if we look at example number 2 is a little different. So what we're going to do is ramp things up a little bit. I want to take the derivative of u to the negative 1 du. Well, that's the same as saying 1 to the u du, or 1 over u. And now to do the antiderivative of that, it's challenging because you literally have u to the 1. But remember, this is just one of those, this is the derivative. In other words, I don't know if you guys recall this, but if I were to take the derivative of the natural log of u, I get 1 over u du. Right? And then because we don't have an upper or lower boundary, we're not calculating the area under the curve, we're just finding the antiderivative, right? And so one of the terms for this is that this is called an indefinite integral. An indefinite integral. And then a definite integral, we have the upper and lower boundaries. So what your textbook wants us to do, this is kind of easy if you've memorized the relationship of the natural log of the absolute value of u, and then if you take the derivative of that, you get 1 over u. Well, we've got to verify that. One way that you could verify that, actually I'm not going to verify it right now, because we already verified that when we covered that for the derivatives. Okay, so what does this mean? Well, and there's a Quizlet app that has all these same formulas, but we're just working backwards. We had a bunch of derivatives, and they were special cases, but for this particular section on page 322, we have a whole bunch of common integrals that are, they're not common, like easy to find, but you just kind of memorize them, and we verified all those when we did the derivatives, okay?